All right, number 31, solve the equation. So if we write this logarithmically, we're going to have log base x of 16 equals log base 2 of x. And we will write this with log base 2. And so change of base there. So we've got log base 2, well, that's going to be 4, because 2 to the 4th is 16, equals log base 2 of x squared. So then we're going to have square root is plus or minus 2, equals log base 2 of x. So x is going to be 2 to the plus or minus 2, which is 4, or 1 over 4. All right, 32, write it exponentially. So 4 plus 1 is 5, and we'll have log base 2 of 5 equals x. 33, we can write e to the 0 is e to the x plus 2e to the 2x, and this is going to be quadratic, and e to the 0 is 1, so minus 1. So just write it like this, and we have 2w and w, and 1 and 1, and we have positive 2 and negative 1, and so w, which is e to the x, equals 1 over 2, or e to the x equals negative 1 here, no solution. And this, we have natural log of base e of 1/2 equals x. We can also write that as 2 to the negative 1, or negative natural log 2. So any of those. Okay, so for this one, I've already graphed it on the graphing calculator. You get the absolute value here by going to this one. And it's it's the one that's highlighted there, okay? So we just have those 3 intersections, and that's the answer. So we should have x equals negative 2.50 or negative 1.51 or 0.440. The other way you can do that, just when we get into absolute value, is you could have just graphed this equal to 2 and that equal to negative 2 and found the intersections. All right, so for number 35, the common ratio of the terms in a geometric series is 2 to the x. So r is 2 to the x. State the set of values of x for which the sum to infinity of the series exists. So for a geometric series, sum to infinity, to exist, we have that r, absolute value of r, has to be less than 1, which means r is in between negative 1 and 1, but r is not equal to 0. So if we think about our r, which is 2 to the x, first of all, 2 to the x is never going to be a negative number. So we can just write this like this. Okay? Second, if you think about values that x can be, they can be negative numbers, 0, or positive numbers. All right? So anything after 0, if we have 0.1 or 0.5 or 1, these are all greater than 1. So if we have 0, then it's equal to 1. 2 to the 0 is 1. So if we have negative numbers, this is doing 1 over 2 to the whatever. So it's going to be all the x's less than 0. If the first term is 35, find the value of x for which the sum to infinity is 40. So we've got u1 over 1 minus r, and we want this to be equal to 40. So if we cross multiply, subtract 40, which is -5, divide by -40, that's 1 over 8. And right there we can see x is -3. All right, a group of 10 leopards is introduced into a game park after T years. The number of leopards N is modeled by that. How many leopards are there after 2 years? So this is in years, and we just have to substitute in 2. Okay. For B, how long will it take for it to reach 100? So we've got 100 equals 10e to the 0.4 t, and solve for t with n solve. So for C, how long will it take for the number of leopards to double? So if we started with 10, because that's the initial amount, if we substitute in t equals 0, that's the initial amount. So we want 20. And again, you can n solve. Okay. 37, population P of bacteria at a time t is that. Calculate P when t is 0. So P should be 100 because e to the 0 is 1. How long will it take for the size of the population to double? So we want 200. And then you can n solve. The mass of radioactive substance is that. Write down the initial mass. That's at t equals 0. So m is going to be 4. The mass is reduced to 1.5. So if we do 1.5 equals e to the negative 0.2 times t, and n solve, we get that answer. C is the half-life, so that's when half the amount exists. And n solve again. A machine was purchased for 10,000. Its value V after t years is given by that. The machine must be replaced at the end of the year in which its value drops below 1,500. So we just have 1,500 because that's its value equals this, and you should n solve. All right, the area A kilometers squared affected by a forest fire at time t hours is given by that. When t equals, okay, so we've got 1.2 equals 1 over e, they give it to us, e to the k times 5. And you should, well, it says show, so don't do that. So you can write 1.2 equals e to the 5k minus 1, because we've got 1 being divided by, and then we can natural log 1.2 equals 5k minus 1. So natural log 1.2 plus 1 over 5 should be 0.2. Find the value of t when 100 kilometers squared are affected. So we're going to have 100 equals 1 over e to the 0.2 t, and then n solve. Population of bacteria is growing at a rate. So this is going to be 100% plus 2.3%. So 1.023 is your R. So we can do the UN equals U1 R to the N minus 1. And we will have that we want the population to double. So we're going to have initial population twice that, 1.023 to the N minus 1. Except it shouldn't be N minus 1 because we're given, there's something at time 0. So it doesn't start at 1. So this should actually just be N. Okay, so then we're going to have 2 equals this. So natural log 2 equals n natural log 1.023. So we just divide natural log 2 by natural log 1.023. And this equals about 30 minutes because it's given per minute. All right, 42, back to financial. So we've got sums of hundreds invested if the interest is compounded annually at 5% per year. Okay, so we're going to have the future value is equal to 100, 1 plus 5 over 100 times 1 to the 1 times n. So after 20 years, and this is in years, so we'll have 100, 1 plus 5 over 100 to the 20. And I'm not going to do B because it's saying if the interest is compounded monthly at that rate, the total value of the investment exceeds V. So in the mark scheme, it's saying V after 20 years. But it seems like a general V, so they would be more specific about that. All right, there were 1,420 doctors working in a city on the 1st of January 1994. After N years, the number of doctors working in the city is that. How many doctors were there working in the city at the start of 2004? So that's when we just substitute in N is 10. And then in what year were there first more than 2,000 doctors working in the city? So if you do this and N solve, you get that N is 5.8. So that's exactly when there's 2,000. So not until the 6th year is there more than 2,000. At the beginning of 1994, the city had a population of 1.2 million. After N years, the population is given by that. Find the population. So we need to substitute N equals 10. Calculate the percentage growth in population between those two dates. So when for BI, you're going to get the population is 1,540,000. And then that's the three significant figures. So if you calculate the percentage growth, you're going to have the new minus the old over the old. And then you multiply it by 100, and that ends up being 28.3%. So that's double I. So for triple I, in what year will the population be greater than 2 million? So you need 3, do this, and then N solve, and then you want to go to the next number. So this ends up being 20.7 to when you N solve it. So not until the 21st year is the population greater than 2 million. All right, for CI, what was the average number of people per doctor at the beginning of 1994? So if we had 1,420 doctors and the people were 1.2 million, we need to find the doctors. Oh, I think we need to do that 1.2 million over 1,420 because we want people per doctors. So switch those, and this ends up being 845. Okay, so then after how many complete years will the number of people per doctor first fall below 600? So we have people are 1.2 million, and this function models the people, and the function that models the doctors is this. and we want to find when this is equal to 600. So n ends up being 14.2, so not until the 15th year does that happen. All right, a city's concerned about pollution and decides to look at the number of people using taxis. At the end of year 2000, there were 280 taxis in the cities. After n years, the number of taxis is in the city is given by that. So find the number of taxis in the city at the end of 2005. So we're just going to substitute n equals 5 in. So find the year in which the number of taxis is double the number of taxis there were at the end of 2000. So we want 2 times 280 to equal 280 times 1.12 to the n, and you can n solve. So for B, at the end of 2000, there were 25,600 people in the city who used taxis. After n years, the number of people in the city who used taxis given by that. Find the value of P at the end of 2005. So we're just going to substitute in n equals 5. After 7 complete years, will the value of P be double its value at the end of 2007? Justify your answer. So we need to substitute in n equals 7 and see if that's more than 25,600. So it ends up being 46,800, which is less than twice 25,600. Yeah, double its value, 2 times that. I think I just said 25,600. All right, so let R be the ratio of the number of people using taxis in the city to the number of taxis. The city will reduce the number of taxis if R is less than 70. Find the value of R at the end of 2000. So we're going to have 25,600 people use taxis at the end of 2000, and it was 280 taxis. Ends up being 640 over 7. So if you, which is, 91.4. So that's obviously not less than 70. All right, after how many complete years will the city first reduce the number of taxis? So we need the function 25, 60, 1, 2, 3 over 10 plus 90 e to the negative 0.1 n, and we need that over 280 1, 2 to the n. And we want this to equal 70. So when you n solve this, you get n is 9.3. So in the 10th year, they'll reduce the number of taxis. All right, 45. Initially, a tank contains 10,000 liters of liquid at time 0 minutes. The tap is open and liquid flows out of the tank. The volume which remains in the tank after t minutes is that. Find the value after 5 minutes. Clearly, we just substitute in t equals 5. For how long to the near second find how long to the nearest second it takes for half the initial amount of liquid to flow. So that's going to be at 5,000 because the initial amount is 10,000. And you just need to n solve this for t. For C, the tank is regarded as effectively empty when 95% of the liquid is flowed out. So we want only 5% of 10,000 to be left. And you should be able to n solve that. For DI, find the value of 10,000 minus V when T equals 0.001 minutes. Put it into the calculator, hence or otherwise estimate the initial flow rate of the liquid. Give your answers in liters per minute corrected to significant figures. So this ends up being equal to 0.693, and that's liters that have left the tank in 0.001 minutes. So if we know that this many liters have left the tank in 0.001 minutes, when you divide those two things, you get the flow rate, which ends up being 690 liters per minute.